Okay, question 2 is to do with combining formulae and using the rules of algebra. In the exam question, you'll be expected to use a formula like in question number 1, so you can work out surface area or volume of a shape, something like that. And then there might be another part to it, similar to this question, where you're asked to see if you can show me where a formula comes from by deriving it, and then maybe combining that with another formula, as it says here, to come up with something else. So this is where we're using the rules of algebra in this sort of question. So if we look at this one, explain how this formula is arrived at in part A. So that's not starting with this formula and playing with it, it's trying to arrive at this formula, which is the formula for the surface area of a cylinder. So draw a cylinder, and it's got two ends to it because it's a closed cylinder, and a side. So the surface area of this thing is going to be the two ends, which is two lots of the area of a circle, pi r squared. You're not given that formula for the area of a circle, so you're expected to know that. And then, if you imagine this cylinder unwrapped, the sides of it will be a rectangle, basically, where this dimension will be the length, so that will be the same as the length of the cylinder, but this dimension here will be the circumference of the cylinder, which is pi times the diameter, or 2 pi r. And again, that formula you're not given, so remember that the circumference of a circle is 2 pi r, or pi times the diameter. So that means the total surface area is going to be 2 pi r squared plus 2 pi r L, which is the area of that rectangle. So the area equals this. Now if we look at this, we can actually factorise it, and that means to take outside a bracket what's common to both terms, and 2 pi and r is common to both terms. So I can take 2 pi r outside the bracket, and what am I left with inside? What have I got to multiply 2 pi r by to get back to 2 pi r squared? R. What have I got to multiply 2 pi r by to get 2 pi r L? L. So r plus L is what's left inside the bracket, and that's the formula for the area that you're given, where instead of L we've got H, the height of the cylinder, but same thing. So that's part A done. Part B, combine this formula with the general formula for the volume of a cylinder to find the total surface area of a cylinder with a volume of 200 cubic centimetres and a radius of 5.5 centimetres. So, for part B, the first thing is to say, well actually, what is the formula for the volume? Pi r squared L. Combine that with the formula for the surface area of a cylinder. Well, we know what that is now. The surface area is 2 pi r, r plus L, where L is the length, H is the height. Now if we look at the information we're given, we want to find the total surface area of a cylinder where we're given the volume and we're given the radius, but we're not given the length. I don't know the length of this cylinder. So what I need to do here is get rid of L. So this is the formula for the surface area, and what I need to do is replace L in this formula with something else. So I'll rearrange this formula for L. So let's call that 1 and that 2. So from 1, L is multiplied by pi r squared to get the formula volume equals pi r squared L. So divide both sides by pi r squared. V over pi r squared equals L. And now we're going to substitute this into so instead of L in formula 2, I'm going to write this, which has got no L in it. So surface area equals 2 pi r, r plus V over pi r squared. And we've got a new formula now that will allow us to find the surface area of a cylinder where we don't know the length but we know the volume. So now carry on, put the values in and see if you can get the answer out. So putting the values in, I get a value of around about 263 square centimetres to three significant figures.